to AI Signals. Thank you everyone for coming out. It's great to have a big turnout tonight, particularly after our new name and our new rebrand. So I'm really grateful for all these new folks coming out. I am going to hand over in a moment to our sponsors, if I can see them around. Awesome, great work. So for those of you who are new to these events, we used to be called AI and Deep Learning for Enterprise. We're now AI Signals. We have been running events in London for the last few years, and throughout we have been sponsored by Demon, who are a consultancy who do all kinds of cool things. And I will now hand over to Motzi, who will tell you a little bit about them.
I'll just speak into both of them, I think.
Yeah.
Hi, folks. Good to see all of you today. My name is Motze, and I'm a senior consultant at Demon. So in a nutshell, we are a technical consultancy based here in Paddington in London. We do work ranging from DevOps to big data, machine learning engineering. One of our principal consultants is actually going to be speaking a little bit more about some of what we do. So I'll leave the brainiac stuff to him to explain. What I will say is that if you like what you hear about us from Damien, please visit us at the back here. We've got a little merch booth over there. We'll tell you a bit more about what we do. Also, take a look at our website. We have openings for consultants. And yes, thank you.
Cool. So, I'm your host. My name is Hugh. I am a developer advocate at Ivan as of a few weeks ago and long-time organizer here. We're a community that's powered entirely by volunteers, and we're very lucky to have a few. I can see a few in our front row here. Jamari, our long-suffering AV volunteer at the back. We also have some new faces. Marina, who has joined as a new volunteer, just up here at front. If you have any problems this evening, or need to talk to anybody, please find one of us and we'll be able to help out. We have a code of conduct at all of our events. We have adopted the num-focused code of conduct. If you want to find out more about that, you can check it out on the link here. But the short version is be kind to others, do not insult or put down others. All communication should be appropriate for a professional audience, and we do not tolerate harassment of community members in any form. Thank you for helping to make this a welcoming, friendly community for all. Do you want to speak at one of these events? We are always looking for speakers. If you are doing things in the AI space, whether that's tooling, process, ethics, anything applied AI, please do give us a shout. If you're a first-time speaker, worry not. We are always happy to welcome first-time speakers for lightning talks and provide you with any support you may need. As I mentioned before, we are a volunteer-powered event. If you are looking to get involved in community organizing, particularly in the AI and tech space, I like to think we're a friendly team, so please come say hi or reach out on our website. We always have lots of cool things for people to do. So without any further ado, also apologies if this picture is wrong. Chaitanya in the room, a LinkedIn script produces this slide, and I realized I hadn't confirmed if this was the right image. So apologies in advance. Our agenda for this evening. We have the evolution of reasoning from System 1 to System 2 thinking in large language model LLMs from Chaitanya and Pathak. We will then have a short break, followed by Ben Gamble from Ververica, who will be speaking about scaling AI workloads with Apache Flink. Last but not least, we have longtime friend of this meetup, Damien J. Duff, principal consultant at Demon, who will be speaking about beyond multi-agent systems, well-designed AI systems that deliver value. So if I could welcome our first speaker to the stage.
So I'd like to say I do no notes, but my vision is terrible, and I can't look at notes and anything else at the same time, and often can't read them. So these days, I basically just have to wing it. So this event is not brought to you by Ververica. I forgot to delete that slide.
A huge hand for Ben Gamble, everybody.
So, hello everyone. Although I normally say I am the technology sommelier, because my job is mostly just to tell you about cool stuff from Kafka, databases, and AI, and occasionally pair cheese with it, my day job is to be the field CTO at Ververica. And though that sounds often for chief technology, these days it's chief talking. I will talk at you repeatedly. Tell me to shut up if necessary. I will not be offended. So previously, I've spent a lot of time building AI and ML systems. Most of my career has been around the idea of simulations and high-speed data. So at one point long ago, I built an AI-powered logistics company. I built a Google Glass company. A lot of these very foolish in retrospect ideas, but these days it basically translates to, if it was cool, I tried to do it, then moved away before the money appeared, which is the kind of story of my career to date. And particularly these days, I mostly work in streaming data and other things. Just before this, I actually used to work at Ivan, where Hugh and I actually met, worked hosting meetups together. But subsequently, I've moved on to Ververica, and on pretty much everything, I'm so lazy to remember things that I just go by Ben Gamble 7. You'll find me by that on LinkedIn, Twitter, or X as it's known, Blue Sky, and everything else. So, quick question. What is Gen AI? And first, hands up. Who's used Gen AI in this room? Good. So, most of y'all. So, just to set the stage, it's the idea of at least the current large language models say, text in, do some stuff. And that stuff varies wildly, and we would have learned a bunch about it, but apparently not. I was going to reference heavily the talk ahead of me. But no, instead we get text out. This is your kind of classic chatbot type scenario. This is where you use your ChatGPT, your Claude, and everything else, and just get this kind of stuff out. But then we talk about what agents are. Now, hands up here who's used an AI agent deliberately, not just one you're given. Now, my eyesight's bad, so I'm going to say that's about slightly over half the room. And that's quite a change. Because the idea of an agent is to take it from this kind of model to taking an action. Now, this is all just a level set to kind of make sure we're all on the same page. Now, the idea is, of course, that an event comes in, this is the sensor, and then we do some reasoning, some processing, we generate an idea, and we do something with that idea. Nearly always this kind of boils down to some semi-structured data goes in, we do some analysis, and some JSON comes out, and the JSON tells us what to do, like every REST API ever built. And what happens next is, when you start to scale these things out, is you end up with a goal, it hits a queue, you create some tasks via an LLM, and it kind of goes in a bit of a loop until you have things you're supposed to do. And then you end up with some memory of what you've just generated, and then you start executing these one by one, many by many. And the idea of a lot of these agentic systems is that you can basically do a bunch of things one after another. But when you look inside them, all there is still is a prompt, some input, and then some way to respond to that. So this is where it becomes problematic, because LLMs are non-deterministic. This means if you put the same thing in repeatedly, eventually it'll give you a different result. Unless you dial that temperature all the way down, at which point it stops giving interesting results. So you either get things that matter and change, or things that don't and don't. So the value is kind of directly proportional to how random the output can be. And they are actually expensive. Now, they are less expensive by the day, but as you start getting to the bigger models, the more reasoning-powered ones, you get to the point of where you use something like cursor.ai, you flick it onto Max, you put it on the Claude v4 on Opus model, and then you run it for a bit and watch the usage-based pricing has popped up. Please add another $100 to your bill. I did this twice in the last 2 weeks. I am scared to look at what my Claude bill would be, and I think my boss might complain. However, it was very cool. But it does mean that LLM calls, particularly for the more powerful, more potent models, the cost can spiral. And this is where we get back to an even more problematic bit, which is chaining non-deterministic systems. Now, who here has heard of the concept of integration of error? Now, this is me being a very much failed scientist from long ago, and the idea is simple. If there are little mistakes along the way, and you keep adding those results together, the amount of mistakes you have build up over time. And if you keep relying on things one after another that can have mistakes, you're going to get more and more of them. And then if you ask bigger and bigger questions, you'll know that your LLM gives weirder and weirder results, meaning that you start getting this kind of fractal amount of error where you no longer can be sure of anything 10 calls down the chain. Once again, if you've used Cursor, this is when you ask it to build the app and you get a banana. But it's very much one of those things where you do not know what you're going to get as it slowly drifts away from your initial prompt. So what we need determinism, because hallucinations are not good for business. And if any of y'all work in things like banking, that can be really bad. There are already been cases where refunds have been issued by LLMs which should never have been issued. Legal precedents that never existed were being given, and of course mortgage applications have been denied for no good reason. So the last one, at least, no good reason makes no difference. But you get the point of where these things matter and low marginal costs. Now, this is the real kicker for me, and for every single use case I've come across yet, which is if it's cheaper to do with if statements, eventually you will trend to if statements. This is the idea that comes around everywhere in software engineering, which is that eventually your code will be rewritten in C because it was too expensive to be running in JavaScript, in Python, in anything else. And worse still, if it works, we'll want to do it a lot. So your bills are going to go up very high, very fast. I dread to think what some of the margins on some of these LLM-powered use cases are, which are not usage pricing. Because we want to use a lot of things, and this is where scalability comes back. Now, on Cursor, I'm going to keep referencing Cursor because it's the one I've been using today, you get up to 3 windows of chat at the same time. If you try to use most AI-powered things, you can't run more than a certain amount in parallel before it just stops working. You can't take more than a certain number of steps before the determinism goes away, and also the amount of delay on each tool call gets rather extreme. And if it's good, we want more of it. We always want more of a good thing. It's called wonderful. And then fault tolerance. Everything eventually dies. I have lost very large prompts in various systems from the fact that you start talking at one of those ChatGPT windows and eventually the voice prompt just goes, nah, not going to convert that. Or Cursor just dies halfway through and you've got to unwind the whole stack it just did. And you can't really pick up because fault tolerance is not designed into these things because even most agentic systems, there effectively are numerous layers of API called deep and there's no determinism up and down the stack. So let's solve for some of them. So hands up here who's heard of Apache Flink. 1, 2, some. Wow, more than usual. Either I'm doing my job or this is better than I thought. This is the right place. So Ververica originally created Apache Flink back when it was called Data Artisans. In about 2014, it was given to the Apache project. We're a lot like Databricks, except whereas we were founded in Berlin, they were in San Francisco, and they got all the money and then did a really good job with it. We pretended to be academics for a very long time and did a very good job of making Flink the answer to really hard problems, yet the community is small. But it's built around the idea of a robust real-time processing engine for batching and streaming data. So it doesn't matter if your data is a batch or a stream, we don't care, we'll process it. It scales to almost any workload. So every single thing you do in Netflix goes through a Flink pipeline to allow them to decide what you're going to watch next. And you know how it can be rather uncanny at times about suggesting the right thing? Thank Flink. And if you ever be complaining about Uber's pricing, we did the processing, we didn't do the calculation. That's on them. And the rest of the things are things like the biggest shopping day in the world is called Couples Day on Alibaba, where they're processing billions of events per second. And we're the ones actually on our own platform powering that. And all that has to be nice and easy. So you want SQL support, you want easy ETL. And because I feel I must, it's effectively monads over data. Yes, I mentioned monads once per talk. So where Flink comes in specifically in these kind of things is something called complex event processing. Now, this is the idea of saying you want rules over data. Now, not just like SQL rules or transform into X. I mean things like matching. So you want to match a pattern. Say, I saw the first event, and if I don't see the next event in 10 seconds, do this. Or I saw this event followed by that event, that means this thing happened. The if-then-else type logic with timers and transactional guarantees gives you the ability to start chaining logic together with some kind of understanding of what's happened, but also the ability to kind of roll these sort of things together. And like statelessness, idempotency is an ideal, rarely a reality. Hands up who knows what idempotency means. So, not all. Good, I'll explain. So idempotency means if I do the same thing twice, I shouldn't get a different result. And if I say, hey you, for this exact ID, for this exact amount, and I do it 3 times, it'll only happen once. Exactly once semantics are semantics. They're not exactly once behavior. This behavior is achieved through idempotency. So I call my tool chain 3 times because of retries and accidents. It should only ever happen once. And this is where catching those kind of things becomes very important. And this is where something called stateful or stateful functions, built on top of those previous, we mentioned complex event processing things happen. This is the idea of saying, I want to use Flink to guarantee that I can call that AI over there, guarantee that it goes through, retry if it fails, but also then not retry and handle the responses back if I do it twice by accident. The only way to ensure reliability on the internet and any other system is to keep going until you succeed, and then deal with the fact it might come back 6 times. And this is where we start looking at agents again. So we start putting Flink agents all over the place. So we can put our queue in Flink. Flink has memory. We can put our task creation in Flink. It runs Python quite nicely. And we can do execution in Flink. So this is the idea of calling out to external systems with guarantees. So already we've got some steps done. So let's take away scalability. So Flink scales to billions of events per second, not a problem. Fault tolerance, reasonably okay. At any point in the time, we already have a stateful step. We checkpoint every event, and we can do that RPO 0 level recovery to say we have called exactly this many steps in our tool chain. So now we need more than the LLM to go next, because we have two hard problems left, determinism and low marginal costs. Now, the question I always ask myself, particularly when we come to any sort of engineering and new stuff is, have we done this before? Because if you remember from reading about this stuff, the AI winter, famously when AI was never going to come around again, was in the 1970s. So I'm thinking, surely some of this thinking's been done for me, because I don't like doing it if I don't have to. And this is where I come back to something where I actually started my career out in, which is agent-based modeling. Now, you've heard of agentic systems for AI, but hands up here who's heard of agent-based modeling? The same 6 people. Awesome. I see some of you also suffered computer science at one point. And this is a tool called NetLogo, which I did on my physics course when I was trying to simulate things and find emergent behavior out of complex events. So you have a few very simple rules and a bunch of agents running around obeying those rules, and famously they cause things to happen. The previous slide is something called Craig Reynolds Boids. This is like that flocking behavior you'll all have seen in many game dev things where they go, I can do scale! And the idea is you make things that look like life. And there's only 3 rules being applied over and over again, and each thing is individually working like an agent responding to those rules. So let's talk about research. So in 1971, yep, we can go back a long way now, there's something called strips modeling came out. And this is a whole thing out of Stanford about how you model behavior and decisions in behavior. Because most agent systems these days are just making decisions. Then there's this thing called Sugarscape, which is a book about doing this kind of decision-making agentic stuff at crazy scale, 1996. And then there's a thing called GOAP, or Goal-Oriented Action Planning, came out in the early 2000s and powered some very famous video games. And games like Fear or First Encounter Assault Recon, if you've seen that, and Shadow of Mordor about 7 to 10 years later. I would go into more detail, but I've trimmed those because the graph theory gets hairy at that point. And it's cool, but it goes a bit deep. So let's start putting this together. So we want to define a goal. And in most of these systems, particularly the ones with older school decision-based behaviors, you set a goal. This is a heuristic to say this is what the system is trying to reach. And we can use an LLM to define what the steps to get that goal are, but we can do a bit better, because then we can use a plan. And planning systems, like pathfinding systems and others, are based on heuristics and cost. This is like how your SQL optimizer works inside your database. It makes a plan, tries to arrange things, sees if the cost is low enough, tries again. If the cost is low and it meets some heuristic, it stops and goes, this is good. And then once we have the plan, we can execute it in a queue and have memory attached. But the fun part here is the LLM is all the way only in one place, because if failure happens, let's say you get halfway through your tool chains, the classic example is, of course, booking some travel thing. Maybe you've got the flight, there's no transfer taxis, and the hotel is booked out. So what do we do then? Do we throw away the chain and start again? No. Instead, we throw what we know we have achieved so far back into the plan, we find what's missing in the plan, and then we generate those. These plans are designed to run in microseconds, not the seconds you get in most LLM calls. I have demos of this kind of planning systems running with 1 million running on my old 10-year-old MacBook Pro. Like 1 million agents making plans every single tick. And this is how games have worked for ages. If you ever played Age of Empires, when those villagers chose which tree to go to next, those are agents making decisions in microseconds, not milliseconds, not seconds. So we've already known how to do this for a while. So the question is, why don't we do it like this? Because we wanted determinism. Now, planning is cost-driven and repeatable, because you have to be able to do it over and over again, because the heuristics don't change, therefore it'll always come out with the same answer. But the best thing is, it's local only. And the marginal costs get lower and lower over time because we don't need to call the LLMs over again to do the same action or make the same plan, because we've already made the decision of what we're trying to achieve. We've already built the steps. We've already chosen which APIs to call. Then it's just a cost-based optimizer to say, well, I wanted a burger, you wanted a hot dog, great, we'll just make that at a deterministic level and leave that alone. The LLM calls become marginally less per setup. Now, scalability is fun. We've had people run at about 7 billion events per second on our platform. You don't need to go that fast, but if you do, please tell me. I'd love to hear about it. And the key thing here is that with something like Flink or platforms like it, you just don't have to worry about that problem. Everyone says they can build microservices. I know, I said this before myself. And then I tried to scale them reliably, and then they died, or they crashed, or I had to deal with the fact that the scaling was nonlinear amongst them. And I needed to have, I had a weird blocking point where I couldn't have parallelism. These things emerge and are very complicated, but at least when the framework was designed to handle this, it's one less thing I've got to do as a developer. And of course, fault tolerance. Now, who here remembers the saga pattern of the good old enterprise integration patterns? This is the idea that two-phase commit sucks, but transactional guarantees are really important. Because if I fail to book my delivery of my food, I want to undo the payment and the order at the restaurant, not just the fact that I couldn't find the rider to deliver my food. So these are the steps you need to be able to unwind. Because if you make a plan, you've got a list of everything you're about to do. And when you decide that thing times out, you've got a list of everything you need to undo. And fundamentally, these are what we can do here, because an LLM call fails halfway through its tool calling journey. Unless you've built the plan separately again, are you going to call an LLM to try and undo the damage it just did? That kind of sucks in my mind. So how about you try some of this yourself? Now this is where I give out some free keys to our software, but mostly it's just because, one, this stuff's all open source. I just happen to have a hosting platform for it. So to start with, you'll need an LLM with an API. Almost any of them will work. Ollama is free. I recommend Apache Flink. This is our cloud. It's free for the first $400 sorted. But Apache Flink is also just a free download. And in Python, it's literally pip install. Have fun. It's good fun. I will share libraries about it later. Then some libraries. So LangChain for J, this is an actual open source library I helped build for Flink to do LangChain in Flink. This is the Java version. The Python version sucks. I don't like it very much. And I'm mostly a Python dev. The problem here is that LangChain for J was built by a bunch of very opinionated open source developers, mostly at Red Hat. Whereas LangChain, the first one, was basically built at a startup trying to do a land grab. Don't get me wrong, I respect the hell out of their land grab. It was very successful. But it means there is no strong opinions in that code base, and it's a mess. Also, we're talking about scale here, so I'd prefer the JVM to the Python to CPython if I can get away with it. And then you want help and support. So come find me or anyone else online. I'm Ben Gamble7 everywhere, as mentioned previously. On LinkedIn, I have a squirrel and the blind stick on my LinkedIn profile. It will say follow because creator mode, but if you hit follow, I'll add you back immediately. And then just bug me about cool stuff, and I will talk about it incessantly. So thank you very much for listening. I believe this is my LinkedIn.
So before we go on to our final talk of the evening from Damien, we have some quick community announcements. If you are running an event in London about data, AI, or otherwise in the tech space, and you'd like to plug it here, please do give us a shout. We always want to collaborate with other communities and help uplift each other a little bit. So first things first, the PyData London conference is coming up in 2 weeks. If you don't know what PyData is, they are a meetup group that's international, so they have chapters in cities all over the world, focused on all things Python and data science. And they help to support the NumFocus charity, which if you don't know what NumFocus is, aside from providing us with our very nice code of conduct, they support lots of open source scientific Python packages. So if you've used Pandas, NumPy, SciPy, they are supported by NumFocus. This is a 3-day conference covering all kinds of interesting topics. They have workshops on the Friday with things like AI and learning how to do Pandas and Iceberg, and then 2 days of talks and socials. If you would like to buy a ticket, there are still a select few available, so head over to pydata.org/London 2025. We have one more community announcement. Leo is giving me a meaningful look. Better come over here, Leo, to announce your thing. There we go.
Hi. Hello, yes. So, oh, crap. Haven't even shielded my thing. Right, hands up. Who's worked at a good company? Right, lovely, great. M2. Hands up. Who's worked at a bad company? Okay. Well, I've worked at some good companies. I've worked at some bad ones. And the main thing that separates the good ones and the bad ones, sometimes it's the management, sometimes it's the people I work with, but a lot of it is how easy it is to get my job done, right? And how easy it is to actually ship changes. And the difference between sitting on your hands for 2.5 days and actually shipping stuff is the tool, right? And so a couple of friends and I are writing a book about tooling. We started out thinking about CI/CD workflows and how do you do those right, and AI-assisted workflows and blah, blah, blah. But we slowly began to realize that a big part of it also is the culture of the organization, right? A big part of it is the change management process. A big part of it is how do our organizations actually convert customer requirements into outputs. And so we want to give you guys tools to build organizations where developers actually work, right? How do you run blameless postmortems? How do you do change management, and how do you use it to build consensus? How do you run a good, how do you design good local development environments? And how do you do inner sourcing and stuff like that, right? We want to give you the recipes to follow. We want to give you the anti-patterns to avoid. And above all, we would like to do a book, but unfortunately, we need your help. So this is where you come in. I'm running a roundtable somewhere in London on the 19th of June. Please scan the link. It's a Luma. It will take you to the page. You can put your details in. And if you would like to come have dinner with a bunch of engineering managers, engineering leaders, and cool people, and talk DX, then scan the link, sign up, and hopefully I'll see you there. Thank you very much.
So I work for this company, Demon. I've been working for them since about 2019. This thing is slightly frustrating. I've been working with them since 2019, and I've been quite lucky in that I came from academia into industry at a time when AI was quite important, right? But it was also entering a phase of a little bit of disillusionment, perhaps a little bit of a decline in the hype cycle. But for the last couple of years, we've had a bit of a resurgence, right, in AI, generative AI-led resurgence. And when we think of this resurgence in AI, it is mostly LLMs, right? Generative AI also includes things like image generation. But AI has been, well, ticking along, despite, the fact that machine learning was mostly, in the industry, because I sometimes mix up what's happening in the research community and the industry at the same time. In the industry, you would have seen a lot of machine learning. You would have seen a lot of predictive models, big data, things like that. Within the industry, that's where things were going. Whereas in the research area, well, you were seeing lots of different things, special purpose models. All the alpha stuff was going on, autonomous cars, computer vision, right, was a big deal. I was working in robotics, cognitive robotics, where sort of neural networks and deep learning were becoming quite important. And lots of domain-specific stuff, life sciences and so forth. Where am I going with all this? Well, I was quite lucky that I was front and center, right, with a variety of different clients, seeing the changes, seeing the applications of generative AI. Because with that perspective, I'm going to think a little bit about the next big thing, right? The next echo, the next rotation in the hype cycle, which is agentic AI, right? Okay, so I might have missold this a little bit, talking about multi-agent AI, but when you think about agentic AI, actually, you're thinking about multi-agents, right? Multiple agents acting autonomously, right? So that's the heart of it, right? Autonomous systems that are acting by themselves. And I think one of the reasons this is hitting now is because, well, a generative AI didn't hit quite as hard as we might have hoped, right? We started to hit a little bit of that disillusionment cycle again, right? A little bit of that decline in the hype cycle. We weren't getting huge gains immediately. We weren't getting, the big impact that we were getting. Actually, but this is, imagine you're a CEO or something like that, right? And you're seeing investment going into generative AI. And you're seeing these big companies, selling what you start to think of as snake oil. And, you want to be able to spend your money on something that is really going to be impactful. Generative AI was going to be a panacea, but it really isn't showing up itself. Now you've got something that is promising to go ahead and do the work for you, right? You don't have to maybe, it's autonomous, right? It's working by itself. You don't have to maybe just understand the problems that you're solving even that well. You don't have to spend a lot of money either. You don't have to spend money on designers and software engineers and so forth. So maybe even the broader data ecosystem, maybe even your business ecosystem. Maybe you don't have to think as hard about that. It's promising a lot. But the purpose of my talk, I come to the purpose of my talk, is to step back to that previous hype cycle, the generative AI hype cycle, because we are seeing actual benefits from generative AI. We are seeing a lot of different business use cases being solved by generative AI, not just helping you with your shopping or having philosophical conversations late at night. And I want to give a few different use cases, a few different case studies where we've used generative AI, oh God, that might be the next big thing. Generative AI to solve real use cases. It's not magic. It's not even particularly autonomous, but it's, and I think the points that I'm going to be making around using generative AI are the same points that I would make about doing any kind of digital engineering. It's about understanding the problems. It's about connecting with the people who have the problems and connecting them up to people who understand the possibilities of the technology, doing proper design, orchestrating the technology, controlling the inputs and outputs at the very least, but controlling the systems that you're building in order to basically design the whole thing around producing value. So I'm going to go through a set of use cases that we've tackled as Demon, right? That's the consultancy that I work for. We've been working with a bunch of different startups in the cloud space, in AI, generative AI. We do a bunch of stuff as well around AI hosting, AI training, the lower level stuff of AI as well. But the stuff that I'm going to be focusing on today is the applications of generative AI. Right, so these are the companies that we've been working with, startups. I think today I'm only going to be focusing on the top three. As I said, the characteristics that all of these share is that you can look at these solutions as if they were agentic, but that's not the characteristic that makes them succeed. The characteristic that makes them succeed is that we worked with these companies in order to understand the possibilities of AI for them, and we matched up the AI solutions with real business problems. And you can see, from here that the solutions are only in part AI, right? Actually, when generative AI hit big a couple of years ago, people were also talking about agents then. There weren't quite the same agents that we were talking about today, but basically multiple uses of one LLM almost counted for an agent back then. Right, so I'm going to start with Yagro. Yes, let's wait to the end for questions. So in 2015, this company started up. They started up with a data platform for farmers. So the data platform for farmers, they provide insights for farmers. So they ingest data from various farms. They provide insights like, how is your productivity of your fields? How is your farm performing? How is your farm performing against competitors? How much are you paying for the products that you're using, fertilizer and so forth? All kinds of insights like that they're providing to farmers. But one of the things about farmers is that usually they don't have a massive IT function. They might be using special purpose farming software. They might be using spreadsheets. A lot of the time, if you have an IT function in a farm, it'll be somebody who's working very hard with a bunch of spreadsheets. There is special purpose farming software, and as a data insights platform for farmers, you might be able to ingest from that, but you also have 100 million different other kinds of data that you need to ingest. So we worked with them to understand how AI could be best used to help their business, and they were all in on that. And of course, it all revolved around ingesting data better. And we came up with two use cases that we got some impact, and they were the lowest. We worked with them to understand which AI applications are going to give the best impact for the lowest effort. So the first one is the obvious one, right? So taking unstructured data and making it structured. You've got direct schema ingestion. You've got a schema that you need your data to conform to in order for it to get value. That is very important when you're building a data platform. And you can see this everywhere now. This is everywhere. When we built it, it wasn't quite so popular, but there are lots of special purpose tools that do this, right? Taking unstructured data and producing structured data from it, and that data that conforms to the schema that you need. You have tables that you need to fill. You have an LLM that understands the context. Well, you provide the context. You provide as much context as you need, and is able to fill those tables. You don't need those special purpose tools to do it. It's actually quite simple now with these foundation models. But the existence of those tools show just how much value people are starting to get from that. People are building all kinds of applications just around this. The second use case that we looked at was fuzzy matching. So fuzzy matching, in this particular case, matching entities like product names. So here's an example of product name matching. You might not see it very well, but one says 15% manganese, the other says manganese 15%. Some of them have capital, some of them don't. In order to be able to compare data across different farms, across different fields, across different time periods and so forth, well, you need to be able to match that this product is this product. So you need the names to be able to match. So you need this idea of canonical names. And they had a system for doing that, but it just wasn't that good. And we made unquantifiable improvements to that. We weren't able to measure the improvements because the existing data that they had, the existing human-developed solutions were less good than the LLM-based approach that we produced. And that's gone into production, right? So people are saying, oh, one of the big problems with AI is that you do a bunch of proofs of concepts and they don't go into production. But if you are designing around the needs of your business, then they do. So I could have imagined, doing all of this stuff with agents as well. In the old sense, it is still agents, but I can imagine sending off a bunch of things to try and design how to do this. In fact, one of the use cases that we looked at did involve something a little bit more autonomous, but at the end of the day, it was about taking what worked, fitting into this data ingestion systems in a way that just gets the most value. I started to repeat myself. It's only 10 o'clock where I normally live. Okay, well, I blame children. Okay, so TuckMed's the next case study. So TuckMed's an interesting one. They're a startup that they're producing test kits that you test at home. So they might provide you a test kit that tests for RSV, COVID, flu A, flu B, all in one test kit. And then they connect it up to the cloud. They send that data to your health provider. That data gets used straight to diagnose, to help you immediately. But they're a startup. They're coming to market. And each time they produce one of these test kits, they have to go through a huge design process. Now, we worked with TuckMed to try and find out which AI use cases, or use cases in general, we might provide them the most value. We tended to revolve around that part of the process, not of creating the solution. Later, we need to be able to look at that data and find ways of using that data for knock-on values, possibly with AI. But right now, the big problem that they had was scientists are expensive. Scientists are using all this time to try and understand which clinical uses they might build test kits for, which biomarkers they might be able to, they might need to build these test kits around. And which antibodies, because they're generally using antibody-based approaches on a special graphene sensor, which antibodies they can use to detect those biomarkers. It's a difficult, convoluted process. They need to scan the academic literature. They need to scan the vendor websites. So we built them a proof of concept, a simple proof of concept, a prototype that allowed them to scan a bunch of research papers, distill that knowledge, aggregate it, using AI, each step here with AI, so that they could get an idea of, for each particular clinical use case, what biomarkers are there out there, which antibodies are there out there. And now we're going into, they're using that. They're using that proof of concept in their day-to-day stuff, and we're going into phase 2 now, which is to build that thing out for scale. Think about providing it to other scientists outside of the company. making it bigger, making it work not just with the academic literature, but with the vendor websites that sell the antibodies, so we can aggregate that information together and help them to make their clinical decisions. So again, right, it's again just about working closely with our stakeholders, in this case scientists, understanding their needs. Well, it wasn't just scientists; it was the full company. Obviously, we worked with people who were in product development as well quite closely. But at the end of the day, we found out where the value was, and that was with the scientists, and we worked quite closely with them to produce this prototype. So agentic AI is going to come. It's got its time. It's got its place. But we don't want to lose sight of what we're able to achieve with with the technology that we've got. I'm going to skip this one, and I'll skip this one, and I'll move to this one. This is the most agentic, probably, of the work that we've done, in the sense that it is something that you can talk to that looks autonomous. It's an agent, and this was a chatbot. It dealt with some quite sensitive concepts as well. So one of our main things that we had to do was to control this personality. We call this personality engineering, right? So although it's quite an autonomous agent in the sense that it's something that you talk to, that people will talk to, and it will go off and have a conversation about Roman history or about the personal life story of the person that it represents, it's still all about control, right? It's still all about understanding what messaging you want to get across. More recently also, we've used it as an in situ avatar, physical one. This is sort of heading up the AI transformation of this big company. Don't get me started about AI transformation, but still, it is, again, showing success in the sense that it is something that by allowing them, our stakeholders, to control this, to feed into its behavior and feed into how it responds when it talks to people and so forth, they get the buy-in. They're not afraid that it's going to go and say stupid things that much. But that's what it's all about, right? Because again, it's about working with the stakeholders, trying to understand their needs, and controlling the system, orchestrating the system quite clearly. We've got a lot of different technology in here. We've got an LLM for responding, obviously, but we've got LLMs for testing, LLMs for aggregating the information, in this case, news stories, translating those news stories into different languages in advance as well, to enable the retrieval, speech to text, text to speech, audio to facial expressions, right? There's AI all over the show here, right? This is prime material for agentic stuff as well. But at the end of the day, what was important was that we orchestrate those stuffs in a way that, in particular, I say the word again, control, but that's what it's about. Oh, and latency, right? This particular use case, because it's got the speech to text, it's got the text to speech. Some of the versions have AI-generated video as well. If not AI-generated video, we've still got, we need to take the sound and we need to make facial movements from it. Latency is a big issue here. Again, we couldn't have achieved that low latency if we just, I didn't design the speech to sort of, I didn't want to hit on agentic AI, actually. I wanted to use it as an entry so I can talk about the cool stuff that generative AI is doing now. So I shouldn't keep talking about the, why agentic AI wouldn't be the thing to do this. I'm sure, and I know that there are niches where agentic AI, in the sense that is currently used, because obviously there are many different other ways that we've thought about, various levels of autonomy in the past, is going to be very relevant. But yeah, at the end of the day, I think I've repeated my point quite a lot, right? So I don't think I need to repeat it again. I've just given you a few different use cases where our fantasies of agentic AI might have proven out. But at the end of the day, it was just about good, strong engineering, which is actually, given the state of AI at the moment, it's not about this sort of mystical magic that we used to sell as machine learning. Understanding your data and doing all this feature engineering and mystical stuff like that. Nowadays, you don't need that much data to get good results out of generative AI. So it ends up just falling down on good engineering, good design, good collaboration, and tightly controlling the process and integration. Thank you. This is some of the clients, including the ones that I've been talking about today.